Yeah.
Yep. Okay. And you have two possibilities when it comes to doing hypothesis testing. Okay. And it talks about it here. Has anybody been exposed to hypothesis testing? Elite? Yeah. Okay. So we're gonna. All right. So I was gonna go in a long spiel and everything else, but if I wanted to do this, which is not that bad, right? Oh, I need a marker. Here we go. Here we go. Here we go. Okay. Why don't we talk about the 4 steps, and then I'll talk about, if I get to it, the type 1 and type 2 errors, whether someone is guilty or innocent, right? It's a classic. If you do hypothesis testing, guilt or innocence, and put PDF next to it, small lowercase, you see a ton of stuff come up. And you're going to be like, oh my goodness, it's Murmer talking to me, right? But the biggest thing is we're going to talk about it. We're going to claim some type of stuff, okay? Let's see if I'm going to do this, all right? So we're going to what? We're going to use inferential statistics to do a hypothesis test. Hypot, right? Testing. This will be one of the last 2 things, and we'll talk about errors, all right? So the biggest thing we're going to, overall, what we're going to do is we're going to make a decision. A statistical decision. A decision using the data, using Murmer, via statistics. All right, I had this whole thing I was going to write down, Nick, and I'm like, make it simple, don't go crazy. All right, we're going to talk about the three ways to do it. I think Cambridge doesn't care if it's a right tail, a left tail, or a middle, or 2-tail test, okay? But I want to cover it anyway because I think some of you are going to be taking statistics either way, so I wanted to make sure that you knew what's going on. So a statistical hypothesis is just a conjecture about the population parameter, okay? Whether it's true or not. Mm-hmm. So, if it's true, we assume in the beginning, whatever it is, the thing is true. Mm-hmm. And we talk about that to be H of naught. H-O. Not a ho. H-O. Right? We call that the what hypothesis?
Null.
The null.
The null.
Null. Like null hypothesis. So this is what the data indicates. Like Emily was talking about placebo action and so on, right? That's starting. We've done a whole bunch of tests, and this is what comes out. This is what we start off as true. Now, I know there's people that are religious and so on. I'll stop there. I won't do it. You can prove that a deity might be real or not. Okay? Pascal did this with Pascal's wager as well. And he said it's worthwhile. Oh, go ahead. Yeah. It's worthwhile believing because if you die, you never know what's going to happen to you. Okay? Now, I refuted that mathematically, but it was a fantastic argument. If you look up Pascal's wager, he talks about some of this, even though he was one of the forefathers of statistics. So the first thing is we start off whether this is true or not, right? Not true. So sometimes another way to say this, when it comes to this stuff, all right. Another one is somebody comes up, like you guys, and this is evil teacher, right? Teachers always write about everything. You guys come up and prove, I'm Newton, you're Einstein, right? Mm-hmm. And Einstein said about Newton, oh, I'm sorry, my dear Newton, but you were wrong, right? But both of them are really correct. Newton talked about macroscopic structures, big things above the atom. Einstein didn't. So that's why E equals the sum of F, E of F equals MA was perfect in our world, but in the macroscopic world, string theory and everything else, as well as small subatomic particles, Einstein was correct. So it's really a unique idea that goes on here. So this one, H of A, is what?
Alternative hypothesis.
Hypot.
Yep.
Hypothesis, right? Yes. I had a whole bunch of stuff. How much time do I got?
Some time.
Good, awesome. Sometimes, guy, this is known as H sub 1. I just want you to be familiar with you can write either one, okay? I prefer if you write this way. Ho or ha, okay? Mm-hmm. Okay, ho, ha. Okay. There's a player on the Green Bay Packers that has the last name of Ha Ha. Or is this his first name? I can't remember. He's a defensive back. He's a DB.
Maybe it's because they're talking about their playing style.
Perhaps. I couldn't tell. So,
This is the big character.
null hypothesis is states that there's no difference. Okay? If you really want to know anything, there's no difference between, so we get it, what's called the parameter, whatever we're studying, right? And a value, and a specific value. However, the new kids on the block, not this group, okay? Show my age. This one shows there is an existence. Or there is a difference of a difference between.
Mr. Murmer?
Yes, sir. I'll get out of the way.
ENCE, right? Existence?
Yeah,
Where
am I? Where?
Right where your finger was before? Existence?
Existence.
ENC, that's right. Yeah. All the difference between a parameter and a specific value. And or a specific value, right? So that's what it's really talking about. All right? So I want to go more into this. I wish we had like at least a month, because I think that this is fantastic. You're trying to prove things that are true or not true. Sometimes, instead of saying true or not true, we say when it comes to H sub O, that's the true guy, right? If it's not true, it's H sub A. So when I'm getting into it, you can tell already, right? So if, let's say, the null hypothesis is correct, then we say when the null is okay, so let's say the null is true, and I like you to write that as well. So when we do all this stuff, right, the null is true, we say what? Do you remember what to say, Billy? We accept H sub O. Okay? We accept H sub O.
When we do that, it's null.
So when the null is true, when we're going to do all this data, whatever happens, and I'll show you, there's a four-step method, okay? So to speak. Ooh, calculus. Then when this is true, I accept what they're saying.
Okay.
Now, yes, sir?
So when you said no difference between parameters, is it and or and?
And a specific value.
Okay.
And or a specific value. Okay? That's okay.
Cameron's teaching us how to be investigators.
Well, my opinion, no, but I am. Okay? I told you I'm arrogant, okay? I don't mean to be, but that happens. But sitting here, we're all have a little degree of it.
Null.
So the null, you say, when you're all finished, I'm getting to it, you accept the H sub O. Now, when the alternative is true, so when the alt is true, ALT is true, you can say, yes, we accept H sub A, or we do just the opposite, do not accept, right? Do not accept H sub O. There's a couple ways you can do it, okay? Or we reject H sub O.
Is that an ALT?
ALT, yes. So when the alternative is true, the new kids on the block stuff is true, we're going to throw out the old, in with the new. And you guys then, or your H, okay, you become the H sub O's, and I become obsolete. Oh, into the ether. You see what's going on? All right, a little bit?
HO is the old current hypothesis, and then HA is the new hypothesis you're trying to make.
So the claim of a company says that we can produce X amount of widgets. And you're like, well, I'm going to prove that they can produce more, less, or equal, or not equal to. And there's three possibilities, right? And I got to go through all of them. If I don't get through them, it's okay. All right? So I'm going to tailor whatever we learn, so it's okay. It'll be fine. All right? So you accept, or you do not accept, or you reject, or sometimes you write it this way: failure to reject. Failure to reject. So that means it's a double negative, which is a positive. Does that make sense? I'm trying to stay consistent with the literature that's out there. So you're like, well, wait, we didn't talk about this. What are we talking about, right? So I'm trying to, I know it's a little, well, wow, it's English class, right? But no. So you start off with H sub O, you start off with H sub A. So far, so good? Not bad? No, not bad. Not bad. All right? So there's three possibilities that you compare each one of them to, right? And you can see it right here, right? You have a one-sided, you have a two-sided, okay? I'm going to go through either one of them, right? So this is our little general thing here. I had like 50 pages I was going to give you for that. You didn't want it,
You gave us
okay?
50 pages.
I don't give it. So let's say again. I couldn't hear you, Ellen.
I prefer this a lot better than the notes.
Yeah, because we're going through it together.
Uh-huh.
You know, I'm Virgil and you are the Dantes and Danteesses, right? And we're going to hell together. Sorry, you get the idea. You know, well, that's what
Time to
the
go
furnace.
Charters.
You have to really understand the reading in the last.
That's what I
Okay?
consider
It's a lot better than
Exactly.
coming
Yes.
in every
So,
time.
what do we've always compared everything so far since I've been here when it comes to statistics? We're always using what as our
Success and failure?
yeah, okay, or what's the thing that we're always looking for? The mean. So this here, eighths of O says you look for just eighths of O, right? Whatever that value is, right?
What is that, euro?
It's mean, right?
Oh.
It's mean, mu.
Or me.
Mu and x bar get interchangeable, okay?
So what's that little 0 or O thing?
This is the hypothesis, the null hypothesis is where we're looking at eighths of O. It could be any value, right? We say that the average age or the average test score is, in this example, let's say it's 10 whatever. Has a number to it, right? The average mean of what XYZ company is 10. You guys come along because you're really smart and say, hey, we found out that it doesn't equal 10. It can be eighths of A, right? Sometimes you just write U here, okay? I'm going to be consistent. You don't have to. It can be greater than 10, or it can be what? Less than 10, right?
Yes.
It's not really defined all that well.
Uh-huh. This is what's called a one-sided test. I have to get through this, unfortunately, okay? I think it's fascinating, Sophia, but no one else does, you know? That's why I'm at Starbucks alone crying.
And it's kind of cool.
One-sided test. So, I'm doing math. Yeah, okay. No TV. So you guys remember this thing here, right? Yeah? Yeah? All right. Mean's going to be there and everything else. So,
Pufferfish make that.
usually we have something that's called a significance, right? And you guys know that if we chop this off via z-scores, not the scale, let's go here, right? That's 0, remember? 1, -1, -2, -3, yeah? Remember that? 1, 2, 3, right? Well, we know, usually, right, the z-scores come up with a corresponding probability, right? And that is really what? 60, 68,
68.
95.6, 95, and 99, right?
Yeah.
So what they, yes, go ahead.
7.
99.7 is 95.6.
Was it 99.5?
99.5, right? But they usually just use whole numbers because it's so
Yeah.
low, right? What they like to do is they like to use this one right here, and I know it's up to 2. If it's a two-tail test, this is two-tail. Okay? That means that I am going to reject anything
It's like the
that's
outline.
not inside the uprights. So if I get some value, whatever it is, I don't care. It's a z value, a p value. You can interchange the z and p's, right? You look it up and then you get it. If it exists either over here or over here, you guys win. The young crew wins. This means you reject the HOs. Get rid of those parent. Oh, I should say that because I'm causing revolution, right? H of O, you reject. Well, Murmer, which one's a two-tailed test? You didn't tell us. I did that on purpose. This is when you have what? And it says it on the bottom, right? If you had H of O equals something, right? Let's say 10, just for fun, right? H of A just says, hey,
It doesn't equal 10.
doesn't equal 10. All right? Whatever it is. That's all it says.
So it's
So if you did your test and found out that the Z comes out, we're going to do a test statistic, and then we're doing a population thing with little p, right? If you found out, let's say you found out here, you know, your Z is -4, okay? Boom, failure. You guys win. Do not accept H of not, boom, right? If you found out that you did the test and it's over here, no go, right? You guys win. The new kids on the block win. The H of O is now replaced. Or you just don't agree with what you found. Why do we say it? Why? Why? Besides me saying up here, right?
What do you mean?
Why do we care? I mean, this stuff right here, where it's green, why do we reject it? Yeah, it's 95% is here, right?
It doesn't fall between the statistics that are given.
95% of the data of everything that we've done is there, right? And the table is 0.025, right? Divided by 2, right? 0.025, 2.5%, 2.5%, right? So if it falls in any direction over there, it fails. That's when you said, well, I'm going to prove to you. You come to me and I said, the widgets are 10. And Miss Abear's like, look, she's got glasses on, superb, and says, look, I'm telling you that it's not 10. You're going to lose millions of dollars. She's my COO, okay? And she said, millions of dollars. I'm going to prove it to you statistically. Rock on. And she comes in and says, look, it's over here, and I have found another test that the Z is over on this side. We can't do 10 anymore, Dr. Murmer. Forget it. You can't do it. So I have to change it, or we lose millions. She found out the outlier, right? Because this is 2.5%, all the way there, right? And then this is minus 2.5%. That's why it's a two-tailed test. I wanted to introduce it because Cambridge doesn't do anything of that magnitude. I think that they just say, crank it out and that's it. I think you're smart enough that you could like, oh, well, we got to do a two-tailed test, right? And for us, I'm going to show you which one to do. I'm going to pinpoint you to which one to do, okay? The level of significance here, level of significance, is when p, little p, is equal to, it's not p, alpha, is equal to 0.05. That says, that's 5%, right? So that says 95 times out of 100, 19 times out of 20, we're going to be inside underneath the car hood, right? The other guys is going to be whatever. I will usually give you the level of significance. Okay? If I don't, 0.05. Okay? Yes, sir.
I'm just a little confused, but
Yes, sir.
won't every set of data always have that 5% chance of always being outside?
What if you want to do a more, so I don't like Ms. Abear because she's too statistically correct. So I get somebody else that I'm going to pay her double the salary and go along with me. And they come in and they do 90%. So alpha's 0.1, right? So that means I do what? She's working somewhere else because she's too correct. You know how that happens, right? And what if I wanted something to make it even closer inside? That means I choose less and less, right? I get closer and closer to the true mean. So she's saying, hey, these are outliers. I could, Noah, come up here and make the alpha what? 0.10, right? Remember, this is 0.025, right?
Yeah.
For the tails. And this comes out to be 0.05 and 0.05. That's why we have to multiply by 2.
So,
Okay?
so
I'll tell you that.
a company to say you had 10 or whatever, what could you possibly do to that number or whatever to make it all work? That's what
I can tweak the standard deviation. I can tweak the random variable that I find. And I can increase or decrease the n size, right? A lot that we can do, a lot that you can do. I'm okay with time or no?
No.
3 minutes.
All right, I'll stop there. You blame it on the puffer fish, okay?
Yeah.
The only thing, could you do this for me, even though it's quick? Okay, here, watch. This one here, it's greater than, right, guys? So that means what? This one over here, it's going to be alpha 0.05, just for fun, because I like it. This is where you reject. Now, if it's less than, you're going to go on what side, guys? Well, we're smart. It's the left
The lower
hand
side. Yeah.
And then this is where you reject.
Okay.
Now, sometimes Monday, I'll come in and I'll talk about, you remember all this stuff? No. Okay, I'm going to go over it again. And then, and then I'm going to talk to you about the test statistic. We're going to do something with Noah said. Like, well, how are you going to, this is great stuff, but what are you going to do to do all this? Well, then we're going to compare things, and then we're going to say accept, reject, and so on. Yes, sir.
Oh, no.
Not me. Okay. That's it. All right.
Mr. Murmer,
That's me.
do you recommend that we do any problems like before Monday, or?
If you want, you can try them out, but I haven't got there yet. I've only done half of the stuff to talk about.
Maybe we
And I'll
just.
talk about
yeah.
errors later on. Okay?